So today we're going over the transformation called a dilation. Now, what exactly is a dilation? It's just when a shape on a coordinate plane is either made larger or made smaller. So dilations do not always mean that the shape is being made larger. A lot of people think of dilations when you think of your eyes, when you get them dilated. They either get bigger or smaller. For dilations, we usually call the shape ABC, if that's what we're calling our original shape. Then the dilated shape is A prime, B prime, C prime. So they just have that little apostrophe above it, which means prime. So if I scroll down here, in this picture, my original shape would be the one in blue. So the PQRS. And then our new dilated shape would be the one in green, which is P prime, Q prime, R prime, and S prime. Now, if the original shape is smaller than the new dilated shape, then this dilation is an enlargement. But if the original shape is larger than the new dilated shape, then our dilation was a reduction. So since for this picture here, our original shape is blue, and it is larger than our dilated shape, which is green, this is a reduction. Now, is this shape here a reduction or an enlargement? If I look, the one in the blue is my original, and the one in green is my dilated. And the dilated one is larger than the original, which means it's an enlargement. So right here, again, we want to know, is this considered a reduction or an enlargement? And this would be an enlargement because our original shape is smaller than our new dilated one. So, when we have a dilation, we aren't exactly sure how the two shapes are related just by looking at the picture at first glance. But to see how they are truly related, we are looking at the scale factor. And the order is very important. If we go from our original shape being smaller and dilating it to be larger, then our scale factor is larger than 1. If it's doing the opposite, so we're going from a big figure to a small one, then our scale factor is less than 1. So it will be a fraction or a decimal. So when the scale factor is greater than 1, then this is an enlargement. If the scale factor is less than 1, then it is a reduction. So if I look at the same example from earlier, I need to determine the scale factor. So I want to start by determining which one is my original shape, which would be this blue one right here. And I'm going to record my information into this table. So my original point, I'm going to pick P, I'll label it here. That is at the point 1, 3. Now for R, our original, from our original shape, R is at 1, 1. And our last one, which is Q, is at 3, 1. Now, if I look at my new shape, I want to match it up. So I'm going to do P prime here. P prime, which is up here, is at 3, 9. Let's see. R prime is at 3, 3. And Q prime right here is at 9, 3. So I want to look at my relationship here. What is happening between P and P prime? Well, if I look, 1 times 3 is equal to 3, and 3 times 3 is equal to 9. So what we multiplied by was 3. And I want to see if that's true for our other points. So to go from R to R prime, if I multiply both x and y by 3, that is true as well. And same thing for Q and Q prime. We're multiplying by 3. Which means our scale factor here is 3. So you're just looking to see what you are multiplying by. And this makes sense because this is an enlargement. And we know that our scale factor for an enlargement is greater than 1. So here's some independent work for you all to work on. And then for the second set of notes, we're looking at what if we are given the original picture and the scale factor and are asked to draw the dilated image. Now we can just work backwards, so I'll zoom in here. I'm going to use my scale factor to solve for my new points from my new shape. So I'm going to multiply my x and y's from the original shape to get my points of my new shape. And then I can plot my points there. So if I zoom in here, A is at 3, negative 3. And my point on the new shape, I need to multiply this by 2. Well, 3 times 2 is 6. And negative 3 times 2 is a negative 6. So I can go here, I'm looking for positive 6, negative 6 would give me a point, which is off of our graph, so I apologize for that. So like I said, 6, negative 6 is kind of off our graph, so 6 would be approximately here, and negative 6 down here. So this would be my point. And I'm going to label this A prime so that I know. Now for our point for B, it was originally at 1, negative 3, and I need to multiply that by 2. 1 times 2 is 2, and negative 3 times 2 is a negative 6. So again, I can go ahead and plot my next point. B prime would be at 2, negative 6. And then for C, again, I multiply that by 2. 3 times 2 is 6. 0 times 2 is 0. So my next point would be at 6, 0. Which would be approximately here. And again, this is C prime. So now I'm going to go ahead and connect my 3 points, and there is my enlargement. And then there's the second part of independent work, drawing the dilated shape.